All right, class, welcome back. This is Algebra 2, Axioms of Inequality, lesson 1.6, which you can find on page 15 of your book. All right, now we're just going to talk about strictly the axioms themselves. Remember, an axiom is just a rule that can't be disputed, it's just a law. So here are the mathematical laws, or the rules for the inequalities. You already know the ones for equalities, substitution, transitive property, yada, yada, yada. We're going to do the axioms of inequality, things that are not equal. So here's the first one. Remember, you don't have to memorize these because these are just true from logic. Axiom 1 doesn't have a name, and we say about it what? We say, look, if you have some number, a, okay, and it's less than b, well, if it's true that that same number b is less than some number c, well, doesn't it also stand to reason that a is less than c, right? So you're saying to yourself, what the heck? All right, so basically, here's what you got. You've got some number a, right? Let's call it 3. A is 3. And you say, oh, a is less than some number like, I don't know, b is 5, right? 5 is obviously less than some number c called, oh, different color, let's go with this one, is less than some number 7, okay? So it stands to reason that clearly if 3 is less than 5 and 5 is less than 7, then, well, 3 is also less than, is less than 7. Boom, right? It's just logical because it makes sense. If you wrote this out in linear form, on this side you would get a is less than b, and b is less than c, so therefore a is less than c. I'm sorry that my less than sign also looks like my c. Here, I'll do this. There you go. Well, it's true on the other side, right? 3 is less than 5 is less than 7. Or 3 is also less than 7. Just makes sense because it does, and that's why it's an axiom, because it's just factual because it's true. Or true because it's factual and it's obvious. 3 is also less than 7. Okay? Boom, boom, makes sense. That's the first axiom. A thing that is less than another thing is also less than the thing that the other thing is less to. Okay? If that doesn't make sense to you, you don't need to know what I said. All you need to understand is that it is true, because that's true. Okay? All right, if you wrote that on a number line, it's going to look like this. You'd say to yourself, oh, this is obvious. A, B, C. A is obviously less than B. B is obviously less than C. Let's say that's 0. Then you would say A is less than C. All right, I think we've got that one down. Let's move on to the second axiom. Axiom number 2, or 2. All right, so with axiom 2, you say to yourself, okay, if I have some number A, and that number is less than another number b, well then, that first number a, if I add to it some other number, it will still be less than the second number b that it's less than, plus that same number c. And you go to yourself and say, oh my gosh, that's too many letters, I don't know what I'm saying. Yes, you do. Again, substitute some real stuff in there. Let's say 3 is less than 5. Well, it has to be true that 3 plus, let's go with, I don't know, 1, make it easy, is still less than, or still proportional to 3, or sorry, is still proportional to 5 plus some number that is the same 1. Okay? Let's make that cleaner. 3 plus 1 is 4. 4 is less than 5 plus 1, which is 6. If you have some number originally a, and you add a number to it, it will still be less than a number that was greater than a, plus that same number. That's where you get your proportions or ratio form, right? 3 is less than 5. Well then, 3 plus 1 should still be less than 5 plus 1. Is that true? 4 is less than 6? Yep. Great. Now you know the second axiom. We good? Moving on. All right. Now we're down here, or up here rather. Axiom number 3. Let's go up here. Axiom number 3. Remember, these just make sense because they are true. All right, axiom number 3 says, if A is less than B, then we got our A's and B's again, and C is less than 0, or C is greater than 0, which means what? C is positive, right? If you did that on a number line, here is 0, and you said to yourself, oh, C has to be greater than 0, well then C has to be some type of positive number, right? If it was less than 0, it would be some type of negative number. But because C is greater than 0, it is some positive number. Anyway, so if A is less than B, and C is some positive number, well then, A times C should be less than, or is less than, B times that same number, C. Okay? Again, you say to yourself, oh, I don't understand what that means. Fine, that's all right. Replace the numbers. If A is less than B, right? So, if A is less than B, let's choose the same numbers we've been using. If A is 3 and B is 5, right? It should be the case that if you multiply it by some positive number, let's say the positive number is, I don't know, 4. And that positive number over here is 4. The ratio should stay the same. Let's see if it's true. 3 times 4 is 12. 5 times 4 is 20. Well, look at that. 12 is still less than 20. The axiom works. So basically, axiom 2 is using addition to say that they are the same or proportional. Axiom 3 is saying you can use multiplication to do pretty much the same thing. And you know that should be true, as you should know, because as we have talked about, multiplication is only repeated addition. So if it's true for addition, it should be true for multiplication. All right, let's move on to the last one, I believe, axiom number 4. Yep, axiom number 4. Pretty simple, right, guys? It's just thinking about it. Axiom 4 says, look, homie, let's use different letters, so I'm tired of A and B. If X is less than B, well, then X times some negative number C should be less, or should be greater than, rather, should be greater than letter B times that same letter C. All right. This one, as you notice, as I even messed it up, has a flipped sign. And why is that true? Well, that's true because of the multiplying by a negative. When you multiply by a negative, the parameters of what you're talking about changes. I'll show you what that means. Watch. Okay. So what we need to know is that multiplying or dividing by a negative flips the script, right? Negatives flip the script. Negatives flip the script. I'll even write that down. Negatives flip the script. Okay, let's show you how that works, right? So if you have, excuse me, if you have x being -3, and you multiply it by some negative number, let's call it -2, right? Actually, we should start one step before. If -3 is less than some other number, let's go with, I don't know, -1, right? Because -3 is more negative than -1. Then what this axiom says is that you should be able to multiply that first lower number by a negative number, let's say it's -2, and then it should make it greater than that second negative number, which is greater than the first, by that same value, and it should be -3 times -2, a negative times a negative is a +6. 6 is greater than 1 times 2, because it's negative times negative, is 2. Oh, is that true? Yes, it is, sir and ma'am. 6 times 2, or 6 is greater than 2. Negatives flip the script. You don't even have to memorize the fact that the negatives flip the script. If you just thought to yourself logically, when you see this happen, if some number, like let's say, I don't know, 2, is less than some other number, I don't know, 7, right? And you multiplied them by the same negative number, let's see what happens. Let's just leave that empty and see what happens. 2 times -3, 7 times -3. You'd get 2 times -3, which is -6, and you'd get 7 times -3, which is -21. And is it true? Oh, we didn't do that right. Here we go. That's why. Sorry, long pause. It should have been written 2 less than 7. My bad. So now there we go. If 2 is less than 7, you multiply by the same negative number. It is true, there we go, that -6 is greater than -21. So ignore that nonsense. You see I paused? Because I was like, wait a second, this doesn't make sense. Because my signs were flipped. All right. I think that's all the axioms. So let's now see these axioms in examples. End of second video.